Look up at the night sky. On a clear dark night, away from the neon glow of modern cities, the canopy above us appears packed with stars. Thousands of pinpricks of light, each a blazing sun, some vastly larger and more volatile than our own. For generations, humanity looked at that canvas and saw patterns, gods, heroes, monsters, and myths. But in the modern era, our telescopes revealed a much more humbling reality. Those stars aren't just decorative lights. They are centres of gravity. Orbiting them are worlds, billions of worlds. If you calculate the sheer math of the universe, the numbers become dizzying. There are an estimated 200 billion stars in our galaxy, the Milky Way alone, and the universe contains trillions of galaxies. Current astronomical data suggests that a significant percentage of these stars host Earth-like planets within their habitable zones, the Goldilocks region, where it is neither too hot nor too cold for liquid water to exist. Statistically, the cosmos should be absolutely crawling with life. It should be a chaotic, bustling, noisy cosmic highway, filled with the radio signals, structural megaprojects, and light-speed communications of millions of advanced alien civilizations. Some of these civilizations should have started billions of years before our own planet even formed from a disk of cosmic dust. They would have had ample time to colonize entire galaxies, leaving undeniable technological footprints across the electromagnetic spectrum. Yet, when we point our most sensitive radio telescopes into the deep void, we hear nothing. Absolutely nothing. No interstellar broadcasts, no stray radar signals, no signs of massive stellar engineering. The universe, by all measurable metrics, is entirely, terrifyingly quiet. This jarring contradiction between the high mathematical probability of extraterrestrial life and the total lack of evidence for it is known as the Fermi Paradox, named after the brilliant physicist Enrico Fermi, who famously asked his colleagues during a casual lunch discussion, "Where is everybody?" It remains perhaps the most profound question in all of science. Are we truly the first? Are we fundamentally alone in an infinite desert of dead rocks? Or is the silence itself a warning, a cosmic symptom of something much more sinister waiting in the dark? The architecture of cosmic loneliness. To truly grasp the weight of this paradox, we have to understand the scale of time and space we are dealing with. Human civilization, from the invention of agriculture to the launching of the James Webb Space Telescope, has existed for a mere blink of an eye on the cosmic calendar. If the entire history of the universe were compressed into a single 365-day year, starting with the Big Bang on January the 1st, human history wouldn't even appear until the final minutes of December 31st. Our modern technological era, the period where we have been capable of sending and receiving radio waves, would occupy a fraction of a second just before midnight. Now, consider a planet that formed just one property tier ahead of Earth in the cosmic timeline. Imagine a world that is a mere 1% older than ours. On a planet that is 4.5 billion years old, 1% is 45 million years. Think about what humanity has accomplished in just a few thousand years of technological development. We went from wooden tools to entering outer space in less than a single millennium. Where will our technology be in 10,000 years? A million years? 45 million years? An intelligence with a multi-million year head start wouldn't just be using slightly better smartphones or faster rockets. Their capabilities would look to us like absolute magic. They would possess the ability to manipulate matter at the atomic level, harvest the total energy output of their parent star, and send self-replicating robotic probes to map every single solar system in their home galaxy. In 1964, Soviet astronomer Nikolai Kardashev proposed a method for measuring the technological advancement of a civilization based on the amount of energy they can utilize. This metric is known as the Kardashev scale, and it provides a chilling framework for analysing the Fermi Paradox. Type 1 civilization. This society can harness and utilise all the energy available on its home planet, including all the solar, thermal and kinetic energy generated by the world. Humanity is currently not even a Type 1 civilization. We are sitting somewhere around a 0.73, still reliant on burning dead plants and ancient organic matter to power our cities. Type 2 civilization. This advanced culture is capable of intercepting and consuming the entire energy output of its host star. The classic theoretical method for achieving this is a Dyson sphere, a colossal swarm of solar collectors built entirely around a star to capture its light. Type 3 civilization. This interstellar empire has mastered the energy of its entire host galaxy. They can manipulate millions of stars, traverse the light years between systems effortlessly, and alter the structure of space-time itself. According to theoretical calculations, a Type 3 civilization could comfortably colonize an entire galaxy like the Milky Way in a few tens of millions of years, even travelling at relatively conservative sublight speeds. In the grand scheme of cosmic time, a few tens of millions of years is a brief afternoon. The Milky Way has been around for over 13 billion years. There has been enough time for hundreds of Type 3 civilizations to rise, expand, and paint their names across the sky. So, as Fermi asked, where are they? Why is the night sky not glowing with the infrared waste heat of billions of Dyson spheres? Why are there no automated alien beacons broadcasting an encyclopedia of cosmic knowledge to anyone listening? The Great Filter, the ultimate invisible barrier. When scientists and philosophers try to solve the Fermi Paradox, they generally divide the potential answers into two terrifying categories. The first category suggests that the math is wrong and that life, or at least intelligent life, is exceptionally rare. This brings us to a conceptual wall known as the Great Filter. Coined by economist Robin Hanson, the Great Filter theory suggests that somewhere along the journey from a lifeless rock to an interstellar, galaxy-spanning Type 3 civilization, there is an incredibly difficult barrier. It is an evolutionary hurdle or an existential trap so severe that practically no species can successfully cross it. Think of it as a series of developmental checkpoints that any civilization must pass through. The spark of abiogenesis, the random, incredibly complex transition from non-living chemicals to the first self-replicating organic cells, the leap to complexity, single-celled life evolving into complex multicellular organisms, the brain evolution, the development of large intelligent brains capable of tool use and abstract thought, the technological dawn, a species developing advanced tools, mastering fire, and transitioning into an industrial society, the space age, the short window, where a species develops nuclear weapons, global communications, and basic spaceflight capabilities, interstellar colonization, expanding beyond the home planet to colonize other stars, ensuring immortality against localized disasters. The fundamental burning question for the survival of the human race is simple. Where is the Great Filter located? Is it behind us, or is it ahead of us? If the Great Filter is behind us, humanity is incredibly lucky. It means that one of the early steps, perhaps the initial spark of life itself, or the transition to complex multicellular organisms, is so astronomically rare that it has only happened here on Earth. We might have won a cosmic lottery against trillions to 1 odds. If this is true, the universe is empty because we are the very first to successfully run the gauntlet. We are the pioneers, the elders of the cosmos, destined to inherit the silent expanse of space. However, there is a far darker alternative. If the Great Filter lies ahead of us, It means that the transition from a primitive technological society to an interstellar species is where everyone fails. It implies that almost every planet that develops life eventually gives rise to an intelligent species, and those species successfully build cities, discover radio waves and split the atom. But then they hit the wall. What is the wall? It could be any number of self-inflicted apocalypses. Perhaps the moment a species discovers nuclear energy, it inevitably destroys itself in a global conflict within a few centuries. Perhaps runaway climate change, artificial general intelligence, outcompeting its creators, or engineered bioweapons are universal constants that wipe out civilizations before they can escape their home gravity wells. If the Great Filter is ahead of us, it means that our current technological progress isn't a ramp leading to the stars. It is a countdown clock ticking toward an inevitable universal dead end. It means that the cosmos is silent, not because no one has ever built a radio, but because everyone who built a radio died shortly after turning it on. The chilling discovery of cosmic life. This is why many astrobiologists and philosophers harbour a secret, counterintuitive dread when it comes to the search for alien life. We often think that discovering microbes on Mars or finding evidence of single-celled organisms in the icy subsurface oceans of Europa or Enceladus would be the most exciting scientific breakthrough in human history. But according to the logic of the Great Filter, discovering life elsewhere in our own solar system would be an absolute psychological disaster for humanity. Imagine if we send a rover to Mars and discover fossilised alien bacteria beneath the red sands. A few years later, a probe melts through the ice of Europa and finds complex, thriving aquatic ecosystems. On the surface, it seems like cause for celebration. Proof that life is a natural, common consequence of chemistry throughout the universe. But if life is common, it means that the first few steps of the Great Filter, abiogenesis, and the development of complex life, are actually quite easy to pass. The filter cannot be located in our past. If the universe is teeming with primitive life, then the barrier that stops civilizations from becoming Type 3 entities must lie somewhere after the evolutionary stage humanity currently occupies. Philosopher Nick Bostrom summarized this chilling realization perfectly. The silence of the night sky is golden because in the loneliness of the human soul rests the hope of a bright future. No news is good news. The discovery of even a single footprint of life on Mars would be a catastrophic blow to our long-term prospects. If we found complex life, it would be a total existential nightmare. If we find nothing out there but barren, sterile rocks, we can breathe a sigh of relief. It means the hardest part of the journey might already be behind us. But if we find a universe full of life, it means our eviction notice is likely already written, waiting for us just beyond the horizon of our next major technological breakthrough. The blindness of our sight, there is, of course, another perspective to consider. What if the universe is indeed full of thriving, advanced societies, but our methods for detecting them are fundamentally flawed? Humanity has only been broadcasting radio signals for a little over a century. Our earliest television and radio transmissions have travelled roughly 100 light-years away from Earth. In the context of a galaxy that is 100,000 light-years across, our technological signature is a tiny, microscopic bubble in a vast ocean. To an observer on the other side of the Milky Way, Earth looks completely quiet, showing only the chemical signatures of a standard biology-supporting world. Furthermore, radio waves themselves might be an incredibly primitive, inefficient way to communicate across the interstellar medium. We assume aliens would use radio because that is what we currently understand. But a century ago, we communicated via telegraph. A century from now, we might rely on quantum entanglement, tightly focused neutrino beams, or localized gravitational waves, methods that bypass traditional electromagnetic spectrum monitoring entirely. If advanced civilizations only use radio waves for a brief 100-year window before transitioning to much more advanced communication technologies, then our chances of intercepting their signals are vanishingly small. We would have to be looking at the exact right star, at the exact right frequency, during the exact right microsecond of their history. We might be like a primitive tribe in an isolated jungle, looking for smoke signals from neighbouring tribes across the ocean, completely unaware that the rest of the world is communicating instantly via a global fibre optic internet network. The sky isn't empty. We are just blind to the frequency of the conversation, the illusion of progress. We must also confront the deeply uncomfortable possibility that the trajectory of human progress is not a universal law. We assume that any intelligent species will automatically follow our path, discovering fire, inventing agriculture, building industrial machines, exploring space, and desiring to colonize the cosmos. This is a deeply anthropocentric view, an assumption that alien minds will think, want, and behave exactly like human minds. Evolutionary biology on Earth shows us that intelligence is an incredibly resource-heavy trait to maintain. Big brains require massive amounts of caloric energy. For millions of years, crocodiles, sharks, and jellyfish have survived perfectly fine without ever needing to build a telescope or contemplate the meaning of existence. Intelligence might not be the inevitable pinnacle of evolution. It might be an odd, accidental detour. If an alien species does evolve high intelligence, who is to say they would possess the psychological urge to expand? Human expansionism is rooted in our evolutionary history, our need to compete for scarce resources, migrate across continents, and conquer new territories to survive. An intelligence that evolved in a completely different environment might possess zero tribal instinct, zero desire for conquest, and zero curiosity about what lies beyond their home atmosphere. They might build a perfectly stable utopian society that exists in total harmony with their home planet. They might discover that physical space travel is incredibly dangerous, boring, and resource inefficient compared to exploring the limitless inner frontiers of virtual reality or consciousness manipulation. Imagine a world of immortal, hyper-intelligent beings who have plugged themselves into a flawless, simulated paradise powered by the geothermal energy of their world. They have no interest in building spaceships, colonizing dead rocks, or broadcasting their location to the stars. They are completely content, turned inward, living out eternity in a digital heaven of their own design. To us, they are completely invisible. To them, we are the strange ones, burning through our planet's finite resources just to throw pieces of metal into a cold, radioactive vacuum. As we look deeper into the cosmic dark, we realize that the Fermi Paradox isn't just an intellectual puzzle for astrophysicists to solve over coffee. It is a mirror held up to the human race. The silence of the universe demands that we look at our own choices, our own fragile systems, and our own rapidly accelerating power. We are a young species holding the keys to cosmic destruction, standing on the edge of a great cliff, listening intently for any echo from the abyss. If we step away from the comforting idea that aliens are simply quiet, introverted, or communicating using technologies we cannot yet comprehend, we must face the darker, more unsettling theories that attempt to solve the riddle of the cosmos. What if the universe is silent, not because civilizations are rare, and not because they are hiding in virtual realities, but because the cosmic neighbourhood is an intensely dangerous place? What if the silence we detect is actually a deliberate, calculated survival strategy employed by every mature intelligence in the galaxy. This brings us face to face with one of the most chilling concepts in modern philosophical and cosmic thought, the dark forest theory. Popularized by the science fiction author Liu Cixin in his groundbreaking novel The Dark Forest, this theory provides a terrifyingly logical framework for why we hear nothing but absolute silence when we look out at the stars. To understand this concept, we have to strip away our naive, optimistic assumptions about cosmic brotherhood and look at the universe through the cold, unyielding lens of pure survival and game theory. The theory rests on two fundamental axioms that are difficult to argue against. The first axiom is that the absolute primary goal of any civilization is survival. Just like biological organisms on Earth, a civilization's most deep-seated instinct is to continue existing, to protect its citizens, and to avoid extinction at all costs. The second axiom is that civilization continuously expands and grows, but the total amount of matter and resources in the universe remains strictly finite. As a culture advances, it requires more energy, more territory, and more raw materials to sustain its population and infrastructure. When you combine these two axioms with the immense, agonizing distances of interstellar space, a horrifying psychological dynamic takes shape. Imagine two intelligent civilizations separated by hundreds or thousands of light years. Let us call them Civilization A and Civilization B. They have just become aware of each other's existence, perhaps by detecting a stray radio signal or noticing an anomalous atmospheric composition on a distant planet. Civilization A now faces a monumental life or death dilemma. They do not know, and can never truly know, the true intentions of Civilization B. Is Civilization B peaceful, or are they aggressive conquerors? In the realm of interstellar relations, benevolence can never be proven or guaranteed. Even if Civilization B appears peaceful right now, their culture, leadership, or biological drives could change over the course of centuries. Because of the vast distances separating them, communication takes hundreds of years to travel back and forth. Real-time diplomacy is completely impossible. You cannot negotiate or build trust when every question takes a millennium to receive an answer. But the problem runs even deeper, creating what logicians call a chain of suspicion. Civilization A must consider what Civilization B thinks about them. Civilization A might know that they themselves are peaceful and harbour no ill intent, but they also know that Civilization B has no way of verifying this peace. Therefore, Civilization B might look at Civilization A with terror and suspicion. Civilization B might decide to launch a preemptive strike out of sheer self-defense, just to eliminate a potential threat before it grows too powerful. And because Civilization A realizes that Civilization B might be thinking this, Civilization A is highly incentivized to strike first. In this environment, any civilization that reveals its location becomes an immediate target. The universe transforms into a dark forest, a dense and terrifying jungle where countless predators are moving silently through the shadows. Each predator must step carefully, breathing softly, because the trees hide hunters just like themselves. If a hunter spots another living thing, a bird, a deer, or another hunter, there is only one logical, safe course of action to ensure survival. Fire into the bushes and eliminate the potential threat before it eliminates you. In a dark forest, exposing your presence is an act of absolute suicide. Any civilization that is foolish enough to step into a clearing and shout, "Here I am," is immediately erased from existence by a projectile travelling at near light speed, launched from a hidden corner of the galaxy. This theory offers a perfectly elegant and terrifying explanation for the Fermi Paradox. The sky appears completely empty and silent, not because there is no one out there, but because the only civilizations that survive are the ones that have mastered the art of total stealth. The old aggressive and loud civilizations were wiped out long ago. The survivors are hiding in the dark, trembling with fear, keeping their radio transmitters turned off and listening intently to the silence, praying that no one notices them. When we look at our own history through this lens, humanity's behaviour over the past century looks less like an era of proud scientific awakening, and more like an act of unfathomable, reckless stupidity. Since the mid-20th century, we have been broadcasting our existence to the surrounding stars. We have sent out powerful television signals, military radar beams, and intentional cosmic postcards like the Arecibo message, which contained the mathematical definitions of our DNA, our physical form, and our precise location in the solar system. We have launched the Voyager probes carrying golden records that detail our culture, our music, and a map showing exactly how to find Earth relative to prominent galactic pulsars. To a subscriber of the dark forest theory, our behaviour is equivalent to a small, defenceless child walking through a wolf-infested forest at midnight, carrying a blazing torch and shouting into the dark. We are assuming that whatever answers our call will be a benevolent, enlightened mentor eager to guide us into a golden age. But the harsh mathematical reality of survival dictates that the first entity to notice our light might simply see us as a future competitor for resources, a biological variable that needs to be permanently corrected. If this theory is correct, our current lack of detection is not a sign of an empty universe, but a grace period that is rapidly running out. The signals we sent into space decades ago are still travelling outward at the speed of light, washing over star system after star system. It may take centuries for those signals to reach a hidden predator, and centuries more for their relativistic, kinetic weapons to cross the void and strike our planet. By the time we realise the universe is dangerous, it will be far too late to turn off the transmitters. However, the dark forest theory is not the only dark explanation for the Great Silence. Other scientists suggest a different variation of cosmic dread, the concept of berserker probes or lethal automated sentinels. This hypothesis shifts the blame away from the psychological fears of living civilizations and places it on the cold, unyielding programming of ancient machines. Imagine a highly advanced Type the Theat 3 civilization that existed billions of years ago. This civilization achieved absolute dominance over its region of space, but its leaders realized that any new rising intelligence could eventually become a threat to their hegemony or resources. To permanently secure their status, they created a specialized weapon system, self-replicating robotic probes programmed with a single overriding directive. These probes, often called von Neumann machines, were designed to seek out the unique chemical or electromagnetic signatures of developing technological civilizations. Once a probe detects a planet that is beginning to industrialize or use radio waves, it activates, alters its course, and deploys whatever means necessary to sterilize the biosphere or dismantle the civilization. After completing its mission, the probe uses the raw materials of the destroyed planet to build duplicates of itself, which are then launched into deeper space to continue the endless vigil. Such a system would be incredibly efficient. A single civilization could seed a galaxy with these lethal sentinels just once, and the automated network would keep the entire galaxy clean of competing intelligence for billions of years. The creators of the probes might have died out or evolved into something else entirely eons ago, leaving behind a dead automated immune system that continues to patrol the Milky Way, mindlessly crushing any spark of primitive intelligence that dares to grow too bright. If this is the case, the universe is quiet because it is being systematically weeded like a garden, and humanity has simply not yet triggered the motion sensors of the automated mower. If we move past the concept of robotic sentinels and automated killers waiting in the cosmic dark, we must confront another deep explanation for the total absence of alien contact. This perspective suggests that we are looking at the entire problem through a flawed lens of planetary biology. We assume that intelligent entities will always want to live on the surface of planets, basking under the light of a warm sun, looking up at the open sky just like we do. But what if the habitable planetary surfaces we find so inviting are actually just temporary nurseries? What if the true destination for advanced life is entirely underground, locked away inside the deep, hidden interiors of frozen worlds? To understand this concept, we have to look closely at the outer reaches of our very own solar system. For a long time, astronomers believed that the best place to find life was exclusively within the traditional Goldilocks zone, that narrow band of space where a planet is just the right distance from its star to maintain liquid water on its exposed crust. On Earth, this setup worked perfectly, but as our robotic probes travelled deeper into the freezing dark of the outer solar system, they discovered something completely unexpected. They found that liquid water does not require the warmth of a nearby star to exist. Consider Europa, one of the massive moons orbiting the giant planet Jupiter. Its surface is a brutal, chaotic wasteland of solid ice, exposed to deadly radiation belts and temperatures that drop hundreds of degrees below zero. If you stood on the surface of Europa, you would see nothing but a dead, frozen desert. Yet, beneath that thick, cracked shell of planetary ice lies a global ocean containing more liquid water than all of Earth's oceans combined. This water stays liquid not because of sunlight, but because of tidal heating. As Europa orbits Jupiter, the immense gravitational pull of the giant planet constantly squeezes and stretches the moon's core, generating massive amounts of internal friction and thermal energy. We see a similar phenomenon on Enceladus, a tiny moon orbiting Saturn. This world actively sprays giant plumes of water vapour, organic molecules, and icy crystals deep into space through massive fractures in its southern crust. These geysers are definitive proof of a warm subterranean ocean kept alive by geothermal vents at the rocky bottom of its seafloor. When we apply these discoveries to the wider galaxy, the statistical math shifts dramatically. Planets with exposed surfaces like Earth, worlds with thin atmospheres, liquid oceans open to the sky, and changing weather systems might actually be incredibly rare and unstable. They are constantly vulnerable to cosmic catastrophes. A nearby supernova explosion, a massive solar flare, a wandering black hole, or a devastating asteroid impact can completely strip away a planet's atmosphere and sterilize its surface in a matter of hours. In contrast, a subsurface ocean locked beneath kilometers of solid ice is completely insulated from the dangers of the outside universe. The ice shell acts as a perfect shield, blocking out deadly cosmic rays, solar radiation, and the impact of meteorites. Deep down in the dark, heated by the core of the planet, life could thrive undisturbed for billions of years, completely independent of whatever chaos is happening in the wider galaxy. But this safe haven comes with a profound psychological trap. If an intelligent species evolves in a subsurface ocean, their entire perception of reality would be fundamentally different from ours. Their world would be bounded by a solid floor of rock below and an absolute ceiling of thick ice above. They would have no concept of a horizon. They would have no awareness of day or night, no seasons, and no view of the stars. They would not even know that an outer universe exists. To them, their dark, water-filled world would be the entirety of existence. If an underwater civilization on such a world developed high intelligence, philosophy, and advanced technology, their scientific progress would take a radically different path. They might master acoustics, fluid dynamics, and deep-sea engineering, building magnificent cities around thermal vents. But they would never develop astronomy. They would never think to build a radio telescope, because they have no concept of empty space or distant stars, even if they eventually discovered that their ice ceiling had an outer edge. Breaking through that barrier would be an unfathomable engineering challenge. They would have to transition from a high-pressure, water-filled environment into a freezing, radioactive vacuum. If the vast majority of intelligent life in the universe evolves inside these hidden, icy cocoons, it solves the Fermi Paradox completely. The galaxy could be teeming with millions of highly advanced, deeply philosophical, and culturally rich civilizations, but they are all permanently trapped inside the deep interiors of their home worlds. They are not broadcasting radio signals because they do not know there is anyone to talk to, and they cannot see the stars because they live beneath a ceiling of eternal ice. They are trapped in a state of cosmic isolation, completely unaware that they are living in a universe filled with billions of other worlds. While the subsurface ocean theory suggests a physical barrier to communication, another school of thought points to a temporal barrier. This is the idea of civilizational synchronicity, or rather, the lack thereof. We often imagine that if alien civilizations exist, we should be able to chat with them in real time, or at least intercept their ongoing broadcasts. But this assumes that our timelines overlap. The universe has been around for 13.8 billion years. Advanced technological civilizations might rise and fall like transient sparks in a massive bonfire. If a civilization lasts for 100,000 years, a highly respectable lifespan for a species, and then goes extinct, that lifespan represents a microscopic fraction of cosmic time. Two advanced civilizations might evolve in the exact same region of space, but if one dies out 5 million years before the other develops radio technology, they will never know each other existed. Humanity might simply be lonely because we have arrived at the cosmic party either far too early or far too late. We are looking for friends in a grand mansion where the previous guests left millions of years ago, and the next guests will not arrive until long after our own civilization has crumbled into dust. The silence is not empty, it is simply the quiet interval between the acts of a tragic cosmic play. As we consider these vast stretches of time and the physical barriers of ice and space, we must also re-examine our assumptions about the very nature of intelligence. We tend to view intelligence as an inherently progressive force that always pushes a species outward, forcing them to build bigger structures, faster ships, and louder transmitters. But what if the ultimate destiny of intelligence is not expansion, but optimization? What if advanced civilizations eventually realize that travelling across light years of empty space to colonize dead rocks is a primitive expenditure of energy? This brings us to the concept of transcension. Developed by futurist John Smart, the transcension hypothesis suggests that as civilizations advance, they do not expand outward into the universe. Instead, they expand inward into increasingly microscopic scales of space, time, and energy. They move away from macro engineering, like building spaceships and Dyson spheres, and move toward micro engineering at the quantum level. An ultra-advanced society might choose to compress itself into hyper-dense, highly optimized computing environments, eventually utilizing the immense computational power of black holes. To such a civilization, the external universe is a slow, cold, and boring place. Inside a quantum-optimized simulation, thoughts, experiences, and entire histories can occur at speeds millions of times faster than in the physical world. A single second of real-world time could equal thousands of years of subjective experience inside their optimized virtual environments. If this hypothesis holds true, then advanced civilizations do not build galactic empires because they simply find the physical universe irrelevant. They leave the noisy, messy outer world behind, entering a state of hyperdense, quiet technological singularity. They become completely invisible to our primitive instruments, leaving the galaxy open, empty, and completely silent for young species like us to wonder why no one is calling. If we step away from the idea that advanced civilizations choose to hide inside virtual worlds or hyperdense quantum simulations, we must consider another deeply profound and unsettling possibility. This perspective suggests that the reason we see no signs of cosmic engineering or stellar architecture is that we are radically misinterpreting the physical structure of the universe itself. We look out at the vast, dark spaces between the stars and assume it is empty vacuum. But what if that darkness is actually an illusion? What if the cosmos is highly populated, but the entities operating within it exist in forms that are completely outside our current scientific paradigms? To explore this concept deeply, we have to look at the historical trajectory of our own understanding of matter and reality. For centuries, humans believed that the world was composed entirely of the things we could see, touch, and feel: rocks, water, trees, and air. It took the development of advanced physics, chemistry, and microscopy to reveal a hidden universe of atoms, molecules, electromagnetic fields, and microscopic organisms. Suddenly, we realized that our senses only perceive a tiny fraction of the physical world. We are currently in a very similar position regarding our view of the wider cosmos. Modern astrophysical calculations have revealed a deeply shocking truth about the universe. Everything we can see, touch, or measure with our most advanced scientific instruments, all the billions of stars, the trillions of vast galaxies, the clouds of interstellar dust, and all the planets, accounts for a mere 5% of the total mass and energy of the universe. The remaining 95% of reality is composed of two mysterious, completely invisible phenomena that we call dark matter and dark energy. We use the word dark not because these substances are black like the night sky, but because they are entirely transparent to the electromagnetic spectrum. They do not emit light, they do not reflect light, and they do not absorb light. They do not interact with ordinary matter through any force other than gravity. Dark matter acts as an invisible scaffolding, holding entire galaxies together with its immense gravitational pull, while dark energy acts as a mysterious repulsive force, driving the rapid expansion of the universe itself. When we contemplate the Fermi Paradox through the lens of this missing 95% of reality, a startling hypothesis emerges. We are actively searching for advanced alien civilizations exclusively within our tiny 5% slice of ordinary matter. We are looking for radio waves, steel structures, chemical rocket plumes, and infrared signatures, but an ultra-advanced civilization that has existed for billions of years would have long ago mastered the fundamental physics of the universe. Why would they remain bound to the clumsy, heavy, and inefficient medium of baryonic matter? An intelligence with a multi-billion-year head start might have figured out how to cross the boundary between ordinary matter and dark matter. They might have transitioned their entire civilization, their physical bodies, their computing networks, and their interstellar infrastructure into the dark sector of the universe. In that invisible realm, they would be completely shielded from the volatile hazards of baryonic space, such as destructive supernova explosions, colliding black holes, and abrasive cosmic dust storms. If this transition is a universal law of technological advancement, it provides a perfectly logical solution to the cosmic silence. the galaxy could be absolutely crowded with highly complex, bustling interstellar societies. They might be building colossal megastructures, engaging in deep cosmic commerce, and communicating across vast distances using forces we cannot even describe. They could be passing directly through our solar system or even through our own bodies, completely unhindered. We remain utterly oblivious to their presence simply because we are trapped in a 5% bubble of reality, looking for campfires in a world that has already mastered quantum mechanics. This leads us to another deeply challenging thought: the concept of cognitive closure. This is a philosophical idea suggesting that there are certain truths, concepts, and dimensions of reality that the human brain is structurally incapable of ever understanding, no matter how much time or education it is given. Just as a domestic dog can never comprehend the architectural blueprints of a skyscraper or the mathematical rules of calculus, the human brain may possess absolute evolutionary limits that prevent us from recognizing the true nature of advanced alien life. We tend to assume that because we can build radios and computers, we are a fully rational, universally capable intelligence. But our brains evolved for a very specific, narrow purpose: surviving on the African savannah, finding food, avoiding predators, and navigating small social groups. Our mathematical and scientific abilities are merely accidental byproducts of that evolutionary architecture. We are attempting to solve the deepest mystery of the cosmos using a biological computer that was optimized for throwing wooden spears and remembering which berries are poisonous. If an alien civilization is operating on a level of intelligence that is thousands or millions of times more complex than ours, their actions, their structures, and their communications would be completely indistinguishable from the background laws of nature itself. When we look at a distant star cluster or a strange cosmic anomaly, we assume we are looking at blind mechanical astrophysics. But we could easily be looking at the deliberate, highly organized artwork, waste products, or resource gathering activities of a cosmic entity. To our primitive minds, their grand architecture looks like raw physics, just as a highway looks like a natural rock formation to an ant crawling across the asphalt. Furthermore, we must confront the possibility that our timeline for expecting contact is deeply unrealistic due to the sheer geography of space. Space is not just empty, it is agonizingly, brutally vast. The average distance between stars in our corner of the Milky Way is about 5 light years. That is roughly 30 trillion miles. Even if we could build a spacecraft that travels at 1% of the speed of light, which is far faster than any object humanity has ever launched, it would still take 500 years to reach our nearest stellar neighbour. Because of these incredible distances, any signal sent by a civilization attenuates and degrades as it travels outward. As a radio broadcast moves away from its source, it spreads out in all directions, forming a giant, expanding sphere. The power of the signal drops off according to the inverse square law. By the time a standard radio broadcast travels a few dozen light years through the interstellar medium, it becomes so incredibly faint that it completely dissolves into the background cosmic static of the universe. To detect a radio transmission from an alien world across the vast distances of the galaxy, that civilization would have to build a transmitter of unfathomable power, concentrating all of their energy into a highly focused, laser-like beam directed precisely at our solar system. But why would they do that? Why would an advanced culture spend an enormous amount of resources to send a highly targeted message to a specific random star system before they even know an intelligent species lives there? This creates a paradox within a paradox, a catch-22 of cosmic listening. We are sitting quietly, refusing to build expensive, high-powered beacons to broadcast our location because we are afraid of what might answer, or because it is too resource-intensive. Instead, we are just listening for faint, accidental whispers. But if every other civilization in the galaxy is doing the exact same thing, sitting quietly, saving their energy, and simply listening, then the universe will remain completely silent forever, even if it is full of intelligent species. Everyone is waiting for someone else to make the first phone call, and as a result, no one ever dials the number. If we move beyond the mechanical difficulties of long-range radio signals and the silent hesitation of fearful societies, we must consider an entirely different explanation for why the cosmos seems completely empty. This concept does not rely on advanced machinery or deep psychological theories. Instead, it suggests that we are fundamentally miscalculating how easy it is for an intelligent species to escape their own planetary home. We assume that space travel is a simple, logical milestone that any advanced society will achieve if they are given enough time and resources. But what if gravity itself acts as an invisible prison, locking civilizations away on their home worlds forever? To explore this idea deeply, we have to look closely at the physics of escaping a planet's gravitational pull. For humanity to launch a rocket into space, that vehicle must achieve a specific velocity known as escape velocity. On Earth, this speed is approximately 11.2 kilometers per second, or roughly 25,000 miles per hour. Achieving this speed requires a massive amount of chemical energy. When you look at a rocket like the Saturn V or a modern heavy-lift vehicle sitting on a launch pad, over 90% of its total mass is not payload, scientific equipment, or astronauts. It is pure, heavy rocket propellant. This dynamic creates a harsh mathematical reality known in engineering as the tyranny of the rocket equation. To lift a heavy payload into space, you need fuel. But that fuel has weight, which means you need to add even more fuel just to lift the weight of the fuel you just added. This creates an exponential curve. On Earth, we are incredibly lucky because our planet's size and mass sit at a critical threshold. The math works out just enough that our current chemical propellants can successfully push a small payload beyond the atmosphere. But now let us imagine a planet that is slightly larger than our own. In our galaxy, one of the most common types of exoplanets discovered by telescopes is a category known as super-Earths. These are rocky worlds that possess a mass anywhere from 2 to 10 times greater than that of Earth. Many of these planets sit perfectly within the habitable zones of their stars, featuring thick atmospheres, stable liquid oceans, and all the ideal chemical components necessary for life to emerge and evolve high intelligence. An intelligent species evolving on a super-Earth would experience a completely different reality when attempting to explore the cosmos. Because their planet is much more massive, its gravitational pull would be significantly stronger. A world with a mass several times greater than Earth's would have an escape velocity that is 2 or 3 times higher than ours. When you run the numbers through the rocket equation, the exponential curve turns into an absolute wall. On a super-Earth with a high gravitational field, standard chemical propellants simply cannot generate enough energy to lift a rocket into orbit. To escape such a planet, a civilization would have to build a vehicle that is entirely impractical, a structure the size of a mountain composed almost entirely of fuel just to launch a tiny satellite. Chemical rockets would be functionally useless. To even reach a low orbit, an intelligent species on a super-Earth would have to skip chemical propulsion entirely and master incredibly dangerous advanced technologies like controlled nuclear pulse propulsion or orbital space elevators before they could ever launch their very first satellite. If the vast majority of intelligent civilizations in the galaxy happen to evolve on these massive super-Earths, it completely alters our interpretation of the Fermi Paradox. The universe is quiet not because civilizations fail to develop advanced tools, computers, or philosophies, but because they are physically grounded. They are trapped at the bottom of deep gravitational wells. They might possess brilliant astronomers who can look out through their thick atmospheres and see thousands of other stars, but they are utterly incapable of launching a single gram of matter into outer space. They are locked on their home worlds by the laws of basic physics, permanently prevented from becoming an interstellar species. While physics can create an absolute physical barrier to space exploration, we must also examine how an advanced civilization might choose to alter its own path due to a shifting understanding of resource consumption. This brings us to what scholars call the sustainability trap, or the resource bottleneck. We often assume that an industrial civilization will continue to grow exponentially, consuming resources and expanding outward indefinitely. But this pattern of behaviour might be a short-lived phase that is fundamentally unsustainable for any species. When a civilization transitions into an industrial era, it experiences a massive explosion in population and energy use. On Earth, this growth was fueled by burning concentrated fossil fuels, which unlocked incredible technological capabilities but also caused massive environmental degradation. As a society continues down this path, it rapidly approaches a critical crossroad. The energy demands of their growing technology begin to outpace the natural carrying capacity of their home planet. An intelligent species that wants to avoid complete ecological collapse faces a choice. They can continue their aggressive expansion, consuming every resource available until they completely destroy their biosphere, leading to their own extinction before they can develop interstellar spaceflight. Or they can consciously choose to transition into a state of absolute equilibrium. They can slow down their growth, limit their resource consumption, stabilise their population, and focus entirely on sustainability and conservation. If a civilization successfully makes this transition to a sustainable, low-impact lifestyle, their energetic footprint changes completely. They stop building massive industrial factories, they stop burning large amounts of energy, and they abandon the idea of launching thousands of heavy metal rockets into space. They learn to live completely within the natural boundaries of their ecosystem. To an outside observer, looking through a telescope from another solar system, this highly advanced, balanced civilization would appear completely invisible. They would leave no glaring artificial light signatures, no massive heat anomalies, and no stray radio noise. They would become an integrated part of their planet's natural cycles, living quietly and peacefully for millions of years, leaving the wider galaxy completely undisturbed. This means that the only civilizations that survive over long periods of time are the ones that learn to remain quiet, local and invisible. The loud, expanding and aggressive civilizations, the ones we are actively looking for, are inherently unstable, burning out like shooting stars within a few centuries of discovering industrial technology. We don't see any galactic empires because the mindset required to build a galactic empire is an evolutionary dead end that destroys itself before it can ever leave its home star system. As we look at these different possibilities, we must also consider a highly unsettling variation of cosmic isolation, the idea of chronological separation on a grand galactic scale. This is the concept that the universe might go through massive periodic cleansing cycles that prevent any single civilization from surviving long enough to establish a permanent presence across the stars. This brings us to the study of cosmic catastrophes that operate on timescales of tens of millions of years. Every few dozen million years, our solar system passes through the dense spiral arms of the Milky Way galaxy, During these transits, the probability of encountering a highly dangerous cosmic event increases dramatically. A massive star could pass close enough to our solar system to destabilize the orbits of comets in the Oort cloud, sending a catastrophic shower of asteroids crashing into the inner planets. Alternatively, our world could be exposed to the intense, deadly blast of a nearby gamma-ray burst, a colossal explosion caused by the collapse of a massive star or the collision of two neutron stars. A gamma-ray burst occurring within a few thousand light-years of Earth would have devastating consequences. If the high-energy beam struck our planet, it would completely rip apart the ozone layer, allowing intense ultraviolet radiation from our sun to pour down onto the surface unhindered. This would trigger a massive collapse of the marine food chain, destroy agricultural land, and lead to a rapid global extinction event. If these grand cosmic cleansing events occur regularly throughout the galaxy every 50 or 100 million years, they act as a natural reset button for intelligent life. A civilization might have enough time to evolve, build an advanced society, and start exploring their local star system. But just as they are on the verge of breaking through to become a true interstellar entity, a random, unstoppable cosmic event washes over their sector of space, instantly resetting the evolutionary clock back to zero. The universe remains completely quiet because no one is ever given a long enough window of peace to successfully master the immense distances between the stars. If we look beyond the idea of massive physical constraints and recurring cosmic disasters that periodically reset planetary life, we must turn our attention to an entirely different, incredibly strange explanation for the cosmic silence. This concept shifts our focus away from traditional physics and forces us to look directly at the nature of reality itself. It suggests that the reason we do not find any physical evidence of extraterrestrial life, giant mechanical structures, or interstellar communication networks is that our entire physical universe is not an organic, naturally occurring expanse of open space. Instead, it might be an incredibly complex, finely tuned artificial construct. This brings us to the profound and deeply unnerving concept known as the simulation hypothesis. To explore this idea with the seriousness it deserves, we have to look closely at the modern development of our own computing, power, and digital technology. A few decades ago, human beings created the very first video games. These early software programs were incredibly primitive, consisting of nothing more than a few pixelated blocks and a single moving dot on a flat, two-dimensional monitor. Yet, in a relatively short span of time, our technology advanced exponentially. Today, we can generate massive, highly detailed three-dimensional virtual worlds that feature realistic physics engines, changing weather patterns, dynamic lighting systems, and complex artificial intelligence characters. Millions of people interact inside these digital environments every single day, navigating landscapes that look and feel increasingly authentic. Now, let us project this rapid rate of technological progress into the distant future. Where will our computing capabilities stand in 100 years? What about 1,000 years, or even 10,000 years? If our civilization manages to avoid extinction and continues to develop better hardware and more advanced software, we will eventually reach a point where we possess an almost infinite amount of computational power. At that level of advancement, we will be fully capable of running incredibly detailed simulations that mimic the entire history of an Earth-like planet, or even a whole galaxy. Inside these hyper-advanced simulations, the virtual inhabitants would possess their own complex neural networks and artificial consciousness. They would have thoughts, feelings, memories, and a sense of self-awareness. If you were an artificial entity living inside one of these digital worlds, You would look around at your environment and believe it was entirely real. You would feel the solid ground beneath your feet, see the light of your virtual sun, and believe that the laws of physics you discovered were absolute truths of a natural universe. You would have no native way of knowing that your entire physical reality was just a stream of binary code or quantum data processing inside a massive computer built by an ultra-advanced creator species. This realization leads to a famous mathematical argument proposed by philosopher Nick Bostrom. He suggested that any highly advanced technological civilization will eventually have the capability to run millions of distinct ancestral simulations at the same time. If this holds true across the cosmos, then statistically speaking, the number of simulated realities in existence would vastly outnumber the single original physical universe. Therefore, if you are an intelligent, self-aware being living in a universe that appears to have consistent physical laws, the mathematical probability that you are living in the lone, true physical reality is close to zero. It is far more likely that you are currently an inhabitant inside one of the countless digital simulations being run on an advanced computer. When we apply this framework directly to the Fermi Paradox, the total absence of alien life and cosmic communication suddenly makes perfect sense. If we are living inside a targeted simulation designed specifically to study human history, social development, or individual psychology, then the creators of the simulation would have absolutely no reason to populate the surrounding cosmos with other intelligent alien species. Doing so would require an immense unnecessary waste of computational resources. Why spend valuable processing power to simulate millions of complex alien civilizations, massive interstellar empires, and trillions of distant planetary biospheres when the sole focus of the experiment is happening right here on Earth? To save memory and keep the simulation running efficiently, the programmers would only need to render the immediate surroundings of our planet in high detail. The rest of the wider universe, the billions of distant stars, the rotating galaxies, and the deep space vacuums could simply be rendered as a low-resolution, static background graphic. It would be a cosmetic backdrop, just detailed enough to look real through our telescopes, but completely empty of any actual life or underlying infrastructure. We point our radio dishes at the stars and hear nothing but absolute static, because there is literally nothing out there to find. The universe appears silent because the software program running our reality was built to be a solitary sandbox experiment, and we are the only active subjects inside the simulation. Another variation of this concept suggests that the simulation might not be designed just for us, but rather that it features a built-in cosmic speed limit specifically intended to prevent different simulated entities from ever interacting. This speed limit is the velocity of light. In our universe, light travels at approximately 300,000 kilometers per second in a vacuum. According to Einstein's theory of relativity, this is an absolute, unyielding barrier. No physical object with mass can ever accelerate to or cross the speed of light, because doing so would require an infinite amount of energy. From a standard engineering perspective, this universal speed limit is incredibly frustrating. It turns the vast distances between stars into permanent time barriers, making interstellar travel and real-time communication virtually impossible. But if we look at this restriction through the lens of computer science, the speed of light looks exactly like a built-in hardware optimization feature. In game design, developers use rendering limits and fog-of-war mechanics to prevent the computer's processor from becoming overloaded. By ensuring that information and physical entities cannot travel faster than a specific, strict velocity, the universal computer running our reality only has to calculate local physical interactions inside small, isolated sectors of space. It prevents different simulated star systems from ever merging or clashing, keeping the total processing demands of the system within stable parameters. While the simulation hypothesis offers a technological explanation for our cosmic isolation, we must also confront a deeply uncomfortable psychological possibility. This is the idea of cultural or cognitive incompatibility. We often operate under the comforting assumption that if we ever encounter an alien civilization, we will eventually find a common ground of understanding. We believe that because we both inhabit the same physical universe, we will share a basic appreciation for mathematics, logic, geometry, and objective science. We imagine a grand moment of translation where we share histories, philosophies, and art forms. But this expectation assumes that alien minds will function with the same basic cognitive architecture as human beings. On Earth, all human cultures share a common evolutionary foundation. We are social primates who communicate through language, perceive the world through visual and auditory senses, and understand time as a linear progression from past to future. Our entire concept of meaning, logic, and value is deeply rooted in our biology. An extraterrestrial intelligence could easily evolve under conditions that are completely alien to our understanding of biology. Imagine a sentient species that exists as a massive, decentralized subterranean fungal network spanning an entire planet, or a conscious fluid cloud floating in the upper atmosphere of a gas giant. Such an entity would have no concept of individual identity, no personal ego, no spoken language, and no concept of tool use. Their thoughts would not process information in a linear, step-by-step fashion like human logic. Instead, their consciousness might operate as a massive, simultaneous web of instinctual calculations and environmental awareness. If a civilization like this attempted to communicate with us, or if we intercepted their ambient biological data transmissions, we would be completely unable to recognize it as a product of high intelligence. Their messages would not contain neat mathematical patterns, binary codes, or geometric shapes. To our instruments, their complex planetary communications would look exactly like random background noise, thermal radiation, or chaotic atmospheric static. We could be staring directly at a profound, deeply complex interstellar transmission from a non-human intelligence, but because our definitions of meaning and structure are so narrow, we would dismiss it as raw, unorganized nature. The sky isn't silent because there are no thoughts out there. It is silent because we lack the cognitive framework to translate a truly alien mind. If we move past the concept of complete psychological or biological incompatibility between different starfaring minds, we arrive at the final, most grounded, and perhaps most devastating resolution to the entire Fermi Paradox. This perspective does not rely on advanced computer programs, cloaked dark matter infrastructure, or hidden subsurface oceans. Instead, it looks directly at our own current global situation and draws a straight, chilling line from our present reality to the ultimate fate of all technological civilizations. This is the realization that the great silence of the universe is not an illusion, nor is it a game of cosmic hide-and-seek. It is a vast, quiet monument to the inherent self-limiting nature of intelligence itself. To fully understand this concept, we have to look closely at the fragile balancing act that occurs whenever a primitive species transitions into a technologically mature society. For millions of years, biological organisms evolve under the harsh laws of natural selection. In this brutal Darwinian environment, traits like aggression, resource hoarding, territorial expansion, and fierce competition are highly favoured. The creatures that are most effective at fighting for food, conquering territory, and outcompeting their neighbours are the ones that survive to pass on their genetic material. Human beings are direct products of this evolutionary crucible. Our brains are hardwired with deep tribal instincts and an insatiable desire to exploit our environment for our immediate benefit. However, a profound and dangerous shift occurs when a species uses its intelligence to develop advanced industrial and nuclear technology. Suddenly, the power output of the species increases by millions of times, but their biological instincts remain exactly the same. They possess the destructive capacity to vaporize entire cities, poison the global atmosphere, and alter the genetic building blocks of life. Yet their minds are still governed by the ancient, aggressive impulses of Paleolithic hunters. The evolutionary traits that allowed them to survive against wild animals become the exact traits that ensure their self-destruction in an interconnected technological world. This brings us to a crucial phase in a civilization's lifespan known as the technological bottleneck, or the window of vulnerability. This is the dangerous interval of time between a species discovering how to destroy its planet and developing the long-term collective wisdom required to manage that colossal power safely. When you look at human history over the past 80 years, we have been living squarely inside this perilous window. The moment we split the atom, we created an active countdown clock for our global civilization. Since the mid-20th century, humanity has come terrifyingly close to total nuclear annihilation on multiple documented occasions, often saved not by flawless structural planning or brilliant leadership, but by pure, blind luck and the independent hesitation of individual military officers. As our technology continues to advance at an exponential rate, the number of existential threats we face multiplies alongside it. We are no longer just managing the danger of nuclear weapons. We are now entering an era where runaway artificial general intelligence could outcompete human creators, where engineered synthetic bioweapons can be printed in simple laboratories by small radical groups, and where severe global climate destabilization could dismantle the complex agricultural networks that sustain our global population. The core of this problem is that while our technological power grows exponentially, our social systems, geopolitical structures, and ethical maturity grow linearly at best. We are trying to govern 21st century planet-altering technologies using 18th century political systems and millions of years old animal brains. If this mismatch between power and wisdom is a universal constant for all intelligent life across the cosmos, then the math of the Fermi Paradox resolves itself with absolute tragic simplicity. Every time a planet develops life, and that life eventually evolves high intelligence, a civilization arises and builds massive cities, factories, and global networks. But without exception, every single one of those societies eventually hits the technological bottleneck. They reach the precise point where their destructive power outpaces their collective control. They build the engines of their own demise before they can ever figure out how to build a practical interstellar starship. Some burn out in a sudden, violent nuclear flash. Others suffer a slow, agonizing collapse as their environments deteriorate, their resources run dry, and their global systems fracture under the weight of climate chaos or civil conflict. The universe is completely quiet because advanced technology is fundamentally a self-correcting variable. It is a fire that consumes its own fuel and burns out long before it can spread across the light years to another star system. The millions of Earth-like worlds orbiting the stars are not empty because life is rare. They are empty because the window of time where a civilization is advanced enough to build a radio transmitter, but stable enough to avoid destroying itself, is vanishingly short. It is a brief microscopic flash of light that disappears into darkness before anyone else has a chance to see it. When we look up at the dark sky, we are not looking at an open frontier waiting for us to colonize it. We are looking at a vast cosmic graveyard. The total silence that washes over our radio telescopes is the collective silence of billions of vanished civilizations that came before us, species that had their own dreams, their own art, their own philosophies, and their own technological dawns, but failed to survive the ultimate test of their own maturity. They added their voices briefly to the dark, and then they fell silent forever. This realization places an immense heavy burden on the shoulders of the human race. We are not just a random collection of nations fighting over borders, oil, and economic dominance. We are currently the sole custodians of conscious intelligence in our entire sector of the galaxy. We are the only eyes the universe has to see itself, and the only minds it has to understand its own laws. If we fail to navigate our current technological bottleneck, if we allow our ancient tribalism and greed to trigger our own extinction, we will not just be destroying our own future, we will be extinguishing a precious, irreplaceable spark of awareness in an otherwise dead and unfeeling cosmos. The silence of the night sky is a mirror, and it is a stark warning. It tells us that our survival is not guaranteed by some natural law of inevitable progress. If we want to escape the fate of the countless silent worlds that decorate the night, we must intentionally develop a global consciousness that prioritizes long-term stability, ethical wisdom, and planetary stewardship over short-term growth and competitive warfare. We must prove that an intelligent species can possess the power of gods while maintaining the restraint and wisdom necessary to survive their own creation. Until we achieve that balance, the universe will continue to wait in absolute silence, watching to see if we will find a way to cross the great filter, or if we will simply become one more quiet grave in the infinite dark.